So hello everyone, this is lecture 9 for the special theory of relativity, and in the last lecture, which was 8, we studied that how we can just means we can plot any moving frame in the Minkowski's 4D space, and we proved it that it is possible that just by rotation of some axis we can actually plot the moving frame inside that, and then we find this matrix. With the help of this we can find the coordinates in the moving frame in the Minkowski's space by rotation of axis. So the four coordinates can be founded by just using this, and we proved that it follows the Lorentz transformation rule. Okay, so in the today's lecture, let's start with the position four vectors. So what are four vectors? These are nothing but just like we derived this. So these all four vectors are called position four vectors. And what's the definition? Four vectors is a set of four quantities that can be transformed from one inertial frame to another inertial frame with the help of rotational matrix in the Minkowski space. Okay, so that matrix were the set of four vectors, and in that this quantity will remain invariant. This is for the position four vector. This quantity will remain invariant. We already proved this. Now just like the position four vectors, we have momentum four vectors also, and as we in the very before in some lecture we defined the momentum terms and the energy terms. So just like that, here also we can find the momentum and the energy of the moving frame, that is S prime frame, and that can also given by these four vectors px prime, py prime, pz prime, and ie prime divided by c, and that will be given by initial wise this, and this is in the moving frame. So we will use the same matrix which will be used in the position four vectors, and it will give us the same results. Now from this equation, px prime will be gamma px ib gamma multiplied by iec. So if we just product them, gamma px minus ii square will become minus 1, and beta is v by c, so it will give us v by c square e. So see, this equation is a Lorentz transformation equation for the momentum. We already proved this, and just like py prime will be py, and pz prime will be pz, and just like third one is ie prime by c is equal to ib gamma px and this. So if we solve this, beta will be v by c, and gamma, just take gamma common, and what we will get? We will get this equation. I will be cancelled out in both sides, and we multiply c with this, so we'll get e prime will be this, and this is the Lorentz transformation equation. We already proved this in the previous lectures. So this also verifies this, so we call this momentum four vectors. So these are momentum four vectors, and in this quantity is invariant. We also can prove this in the some different way. We know the energy equation. Total energy is equal to this p square c square m naught square c4. Here m naught is rest mass. From here we can just take the p square c square minus e square and m square c square equal to this minus. We can just rearrange, and now we take the c square common. Then here c4 will come convert to c square, and p square minus c square by c square. So it will come like this. So here you can see that this is constant. So this thing remains constant always, because this m naught is not gonna change in any frame, and c will remain same in all frames. So this will remain constant. And what is p here? That p is this px square py square pz square. That will give us p square and e square by c square. So this quantity is invariant. So we can prove this otherwise also. So we get the same result. Now let's come again to the Minkowski's space. Now we will discuss some things, some regions, and we'll see that how things are in the Minkowski space. We just get a better understanding for the Minkowski space. Like see, there are two events. Here we are representing it with CT, means I just for the different thing. That's for the transformations actually. Here we can, if we want to represent this, and we can just represent by CT only. So we are having two events in the Minkowski's space E1, E2. Okay. Coordinates for the E1 is x1, y1, z1, ict1, and for E2 x2, y2, z2, ict2. Now here we don't call is the distance between E1 E2. We will call anything between them is a space-time interval. So space-time interval between events E1 and E2 is given by S12. This will given by, this is space-time interval, will given by this equation. X12 will x1 minus x2 square, y1 minus y2 square, z1 minus z2 square, minus this minus this square, I square will convert to minus 1. So we'll get this. So here S12 square will be del x square, del y square, del z square minus c square delta t square. Okay. So why we are calculating this? Now we will see some things in the Minkowski space, that how this whole space is divided with light and all. Okay. So here just see that S12 square is equal to this, and this is nothing but r square, means this vector will be this r square minus c square delta t square. So in 3D we can write it as S12 square equal to r12 square minus c square delta t square. Here r12 will give us x square plus y square plus z square, the delta or change in them. So this is given by this is space time interval can be given by this form. Okay, now just for the convenience, we just take that motion of any frame or any particle is in just one direction. Let it be x direction. The particle is moving in x direction. Then how we gonna plot this in this Minkowski space? So if it is moving in x direction, then at any time its x coordinate will be given as ut. Just multiply speed with t if it is moving with u speed. If a particle is moving along the x-axis with a uniform velocity u along x-axis, then x will be given by ut. And now just we can replace it u by c multiply ct. We can write it like this. And we already proved that what is u by c? U by c is nothing but tan theta. So here the speed will give us the theta. That's what I told you in the previous lectures also. Theta is related with speed. So if there are different speeds, we will get different thetas and different lines. So x equal to u by c ct. Now x equal to tan theta ct. Here from here we can tan theta equal to u by c and theta equal to tan inverse u by c. Okay. So from this equation we can see that what is the slope? What is slope? Slope is u. If x and time are wait, slope is not this. If it is ct and x, then it is y in this axis. So it will be c by u. C by u. ct equal to c by u x हो जाएगा. So that will give us y equal to mx. Then m will be c by u. C by u. So it is c by u from this side. But if we take the theta from here, it will give us u by c, that is tan theta. Okay. Because tan 90 minus theta is equal to cot theta, if you get it. So slope is c by u. But if we take this as the y-axis and this is x-axis, means just in the case for the finding the slope, so it will give us this tan theta equal to u by c. Just see it again and you will understand what is happening here. Okay, so we can just see this motion of particle in the x direction by this line. We know the theta. What is theta? Theta equal to tan inverse u by c. U is fixed. We know what is the speed and c is speed of the light. So theta will be this. So this angle, just make this angle from here and made a line. This is showing us that it is an equation of a straight line. Okay, because there is this one power only. So it will give us a straight line, and this line is called the world line. The world line, and each event on this line is called the world point. Okay, so that's how we're gonna represent this motion of any particle in this. Now let's say if the particle is photon here. Now it is photon and it is moving. So photon will move at the speed of c. Photon will move at the speed of c. Light photon is traveling along the x-axis. Now the speed will be equal to c. So we will see that x equal to ct here comes, x equal to ct. And if we see the ct and x, then y equal to mx plus c, that equation will give us slope equal to 1. because x equal to ut or ut equal to ct equal to x multiplies only by 1, so that will give us slope equal to 1. So 1 is slope, then theta will be 45 degree, theta equal to 45 degree. And we can see that equation for if it is equal to x equal to ct, then x square c square t square, then this will until came in this x square minus c square t square equal will be 0. Means this line x equal to ct will satisfy this equation. Okay, and it will be at theta equal to 45 degree. Means there is this line for a light, because photon represent light, so this line which is at 45 degree will represent light. That's why we call it light line. Light line. Also it is called null line. Equation is x equal to ct, and squaring both sides will give us x square minus c square t square equal to 0. This will came 0 at all points on this line. Likewise, if the particle is moving in minus x direction, we will get the slope as minus 1. So theta will be 135, and we will get line this. It is also light line or null line. Okay, so we get these two lines for light, and it's not just ending here. It means origin is the point when we start observing. Means when we start observing, this is the point. But before observing, it was also moving. Then it can go in the downside also, this way and this way. It's actually this axis represent the time. This is past, this is present, and this is future. Okay, from this point we are observing. So it was moving at the same line in the previous also. That's why we can represent it like this. Okay, so mainly here we will talk about light. So just hear me out what I'm saying with the open mind, that if we just take this for the x-axis, now we can also say that particles moving in y direction. Y is also perpendicular to all these axes, and same we will get these two lines in all the areas. Two lines we will get that will make 45 angle with y-axis, and same we will get if for the z-axis also, that will make 45 degree. So we'll get a something 45 degree from the time axis. All will make 45 degree with time axis, so we'll get in all directions a cone type structure which is at 45 degree, cone type structure. So if we say that it is moving in y direction, then this equation will be satisfied, the y plus minus direction, then y square minus c square t square equal to 0. This will be satisfied. If it is moving in plus z or minus z direction, then this equation will satisfy, and null line will give us null line. So if we represent is with a general position vector, photon is moving in arbitrary direction, then distance traveled will be given by r equal to ct, and on the squaring we get r square minus c square t square equal to 0, and this we'll get this here, r equal to root x square plus y square z square will give us this. So we can see that this equation is nothing but a equation of cone in 4D, equation of a cone in 4D. So we can see that for light we are getting this type of conical structure. In all the axes we made this structure about or around the ct time axis, which is all axes are 45 degree. Means all null line with in all the axes will make 45 degree angle with it, and it will give us this conical type structure. Hope you are getting this point. This is the equation of cone. This is a equation of cone in 4D space. This cone is called as light cone. The propagation of light is represented by the light cone. Means in all the directions this cone represents the propagation of light in all the axes. Okay, and the space-time interval between the origin and any point. The space-time interval I told you already, that is that distance we talk about, that is space-time interval here. Between the origin and any point on this light cone will always be 0. We already proved this is nothing but space-time interval, and it will always be 0 in all the points which are on this cone, okay. So this will always be 0. Now this light cone can divide the Minkowski's space in 3 parts that we will study. the space-like region, time-like region, and light-like region. So how they are? The light cone divides the 4D space into following three regions: the space-like, time-like, and the light-like. When we call it a space-like, when S12 square will be greater than 0. S12 square is greater than 0. S12 is nothing but the time space-time interval between one and between this origin and this any point or any other event. That space-time interval is greater than 0. So this region, space-like region, came outside the cone. Outside the cone we get S12 square greater than 0, and this region is called space-like. There is this brief idea I will tell you in the detail. Just for the time like, we will get S12 square less than 0, and that region came inside the cone. Inside the cone S12 square is 0. Inside all the cone S12 square will be less than 0, and we will call it time like region. Then there comes the light like region, where S12 square equal to 0, and it is on the light cone. Means all the points which are lying on this cone are called light like region, where we get this equation. This equal to 0 on all points. This satisfies this equation. Okay, hope you get it. Now we will study them individually. First we will discuss space like region. So space like region, first I will just read the statements, then I will tell you on the cone how it is. Space like region is a part of Minkowski's space where S12 square is greater than 0. Okay, we defined it already. So S12 square is nothing but R12 square minus C square delta T square, that is greater than 0. Means this should be greater than 0 to be in the space like region. So what conclusions we can conclude from here, from this equation? This is, in space like region we cannot find a frame in which two events may take place at the same position. We can't find any frame in the space like region where the two events maybe are taking place at the same position. Why? If they are at the same position, then R12 will be 0. R12 will be 0, and if it will be 0, then we will see that this part, my C square delta T square, should be greater than 0, but it can't be greater than 0 because inside this, these are positive and there is negative sign. So this whole quantity can't be greater than 0. That's why it is not possible. Means R12 0 can't be, R12 can't be 0. Means two events can't take place at the same position. That's why. But we can say that if they can take simultaneously in this region, space like region, because if delta T equal to 0 means they are taking place at the simultaneously, then R12 square can be greater than 0, and it will always be greater than 0. Means they can take place at the same time. It is a possibility. However, we can always find an inertial frame in which two events occur at the same time, because if delta T equal to 0, R12 square will be greater than 0. That is possible. Okay, so I will show you these 2 points in this region. Let's say this should be the space like region. So we can see that if these are two events, okay, this is E1, this is E2, these are happening. Okay, now just first see in this first frame only, don't see these all vectors, just they are hidden. Okay, so we have this frame and these are two events. So we can see that just seeing in this frame we can tell that which is happening first and which is happening after. Yeah, of course we can, because we can see there is this time axis. It shows us that time is before or after. So if here E1 is happening first, then E2 happening after, we can tell. Okay, and if we now rotate this frame, now this is the frame, this axis and this axis, this is frame. Here also if we see in this frame, it is happening first and it will come like this, so it will happening after. Okay, now when we come here, we all rotate it more, so this is the frame, this is the frame, there is maybe one axis less, so you can make this. So in this frame we can see that both lie at the origin line, so they are happening simultaneously. Okay, And if we just rotate it more, then we can see that now E2 is at the negative, then it is happening first, E1 is happening after. But in this region there is nothing, there is no possibility that these two can happen at the same position, because there will always be this difference between them, so they can't be at the same position. So that's how we can show these equations here. In S frame, E1 is first event. In S prime, E1 is first event. In S double prime, both E1 E2 are simultaneous. In S triple prime, E2 is first event. So you can see that in the space-like region, we can't define actually that if E1 is happening first, E2 is happening first. These are not fixed. It is depending on the frame to frame. In which frame we are, we can the occurrence or the sequence of event depends on the frame which we are taking. Okay. So we can say that thus in case of a space-like interval, the order of occurrence of two events in time is not definite. That is, any of the event may be first in one inertial frame, and it may be second in the another inertial frame. Just how we see it, that it can be first or second or first. So according to the equation, just let's verify it by the equation also. This should be greater than 0. Now from here, r12 square c square will be greater than delta t square. From here, r12 by c should be greater than delta t. This delta is nothing, delta t is nothing but the time interval between occurrence of event, those two events, between two events. Now this time will be greater than this. According to this, in a space like region, this time will be greater than this. And what is this? It is like two events are happening, and we are this event happened here, even happened here, and we at the same time send this information at the speed of light to the E2 to tell that E1 is happened. So it is traveling at the speed of c. So time will take to for the information to travel from here to here. That will be, if distance is r12 divided by c, this time will be this. And we see that this time is always greater than delta t, the occurrence of the event. So means information will always came late, means always come after when this event already occurred. So according to this person, this E2 will happen first. Then when information came to him, he will see that now this event happened even. So according to him, it's not fixed that what the observer will see. Means it depends that which events is happening first, which events is happening after. So order of the events or the occurrence of the events in the space-like region is not fixed. Okay, you can't just tell that this will happen, this will happen. Okay. So the order of occurrence to events in time is not definite. That's this point you should remember. Okay. And here I gave you the example that if E1 sent the information and it came late before happening this, then he will see that this event is happening after happening this event. And if information reached first, then he will see that this event occurred, then this event occurred. So it's not definite. And in the space like region, we see that this will greater than delta t. So it will always be indefinite, that which event happened first, because information from here to here will never reached on time before this event will already be occurred. It will always came late. So you can't tell that which event happened first in the what's the truly you can't say that. Otherwise in this frame it is happening first, it is happening after this event. Okay, hope you get this idea. I'm just repeating the same thing again so you get the idea. So just hear it again if you didn't get it still, and if you have any doubt, just put it in the comment section. Tomorrow we will just discuss this time-like and light-like reason, then some questions, and this special theory of relativity will be end. Okay, thank you. Just share this lecture to whoever who need this. Okay, and thank you again.